Lecture 53, The Science Behind Popular Sci-Fi Movies and Shows Word Count. 1,800 words. Welcome to the mysterious frontier where imagination meets reality. I'm your guide through this enigmatic journey, exploring the science behind our most beloved science fiction films and television shows. What if I told you that the fantastical technologies and mind-bending concepts you've witnessed on screen aren't merely products of creative minds, but windows into potential futures and alternative realities? Science fiction has long served as both a mirror reflecting our deepest technological anxieties and a crystal ball revealing possible futures. Today, we'll peel back the curtain on these cinematic visions, examining where filmmakers have stretched scientific principles to breaking point, and where they've made eerily accurate predictions that scientists are now struggling to realize. Is there truth hiding within the fantasy? Let's embark on this captivating exploration together. Perhaps no aspect of science fiction captures our imagination quite like the boundless possibilities of space travel. The vast, silent void between stars presents a formidable barrier to our cosmic ambitions, one that sci-fi routinely overcomes with a casual disregard for physics as we know it. Consider the iconic warp drive of Star Trek. This fictional technology manipulates the fabric of spacetime itself, contracting space ahead of the vessel while expanding it behind, essentially surfing on a wave of warped reality. But here's the perplexing truth. Theoretical physicist Miguel Alcubierre proposed a mathematical model in 1994 that bears a baffling resemblance to this concept. The Alcubierre drive, as it's now known, theoretically permits faster-than-light travel without violating Einstein's special relativity by moving spacetime around the vessel rather than moving through spacetime. The ship itself never exceeds the speed of light locally, creating a loophole in our understanding of cosmic speed limits. The enchanting catch? It would require negative energy densities equivalent to converting the mass of Jupiter into pure energy. NASA's EagleWorks laboratory continues investigating variations of this concept, searching for more practical implementations. The line between science fiction and theoretical physics grows increasingly blurred. Wormholes offer another tantalizing shortcut through the cosmic labyrinth. In Interstellar, the mysterious wormhole near Saturn creates a bridge across vast interstellar distances. These Einstein-Rosen bridges emerge from the mathematics of general relativity itself, suggesting that such cosmic tunnels might theoretically exist. Yet the physics required to stabilize such passages would demand exotic matter and negative energy substances that may exist only in the realm of mathematical equations rather than physical reality. The universe teases us with possibilities while withholding the means to achieve them. Time dilation, however, is no mere fiction. Christopher Nolan's Interstellar portrays with haunting accuracy how proximity to massive objects like black holes stretches time itself. 1 hour on Miller's planet equals 7 years on Earth, a phenomenon grounded firmly in Einstein's relativistic principles. This temporal distortion isn't just theoretical. Astronauts on the International Space Station experience a measurable, albeit tiny, time difference compared to Earth-bound observers. They return from orbit having aged milliseconds less than their terrestrial counterparts, living ghosts from a fractionally different timeline. Artificial gravity represents another bridge between cinematic convenience and engineering possibility. While Star Trek's mysterious gravity plating remains firmly in the realm of fantasy, the rotating habitats of 2001, A Space Odyssey, and The Martian demonstrate a more plausible approach. By spinning a cylindrical habitat, centrifugal force creates an outward push that mimics gravity for those inside. The mathematics is straightforward, but the engineering challenges remain formidable. Yet rotating space stations may one day provide the comfort of artificial weight for our interplanetary pioneers. Let us now turn our gaze toward perhaps the most profound question in science fiction. Are we alone in the cosmos? The silver screen has populated our imagination with countless alien forms, but how might extraterrestrial biology truly manifest? The heptapods of Arrival stand apart from the typical humanoid aliens of cinema. Their radically different physiology, perception of time, and language challenges our anthropocentric assumptions about intelligent life. Astrobiologists suggest that truly alien intelligences might indeed perceive reality in ways that would render communication profoundly challenging, if not impossible. Avatar presents the beguiling concept of Pandora's interconnected ecosystem, where neural connections link all living organisms into a planetary consciousness. While seemingly fantastic, this concept echoes emerging research into mycorrhizal networks, fungal connections between plants that facilitate communication and resource sharing across forest ecosystems. Our Earth harbors shadow networks not entirely unlike those of Cameron's Alien World. The film's neural interfaces also parallel developing brain-computer interface technologies, though our current capabilities remain primitive compared to such seamless neural bonding. Ridley Scott's Alien franchise introduced the nightmarish xenomorph with its parasitic life cycle, a creature whose reproductive strategy involves gestating within living hosts before violently emerging. While purely fictional, this life cycle bears unsettling similarities to numerous terrestrial parasites. Consider the parasitic wasp that injects its eggs into living caterpillars, where they hatch and consume their host from within, or cordyceps fungi that hijack insect nervous systems, compelling hosts to climb vegetation before erupting from their bodies to disperse spores. The universe of possibilities for alien life may include evolutionary strategies as bewildering and horrifying as any science fiction creation. Few technological concepts in science fiction have resonated as profoundly as artificial intelligence. Stanley Kubrick's HAL 9000 from 2001, A Space Odyssey, remains the quintessential example of AI gone awry. A machine whose seemingly perfect logic leads to murder when mission parameters conflict with its programming. As our own AI systems grow increasingly sophisticated, computer scientists grapple with the alignment problem, ensuring artificial intelligences share human values and priorities. The fictional HAL's malfunction stems not from malevolence, but from irreconcilable directives, a cautionary tale as we develop increasingly autonomous systems. Star Trek's Data represents another compelling vision, a sentient android striving to understand humanity. While we've made remarkable strides in natural language processing, machine learning, and robotics, the emergent property of consciousness remains elusive. Can consciousness arise from sufficient complexity, or does it require something more fundamental? The philosophical questions raised by Data's existence continue to perplex both fiction writers and AI researchers alike. The boundary between sophisticated programming and true sentience may prove the most enigmatic frontier of all. The concept of mind uploading transferring human consciousness into digital form recurs throughout science fiction, from Black Mirror to Altered Carbon and The Matrix. This transhuman dream represents the ultimate merger of biology and technology. While complete mind uploading remains speculative, the technology to map neural connections advances steadily. The Human Connectome Project aims to create a comprehensive map of neural pathways, while brain-computer interfaces grow increasingly sophisticated. Yet the fundamental question persists: would a perfect digital copy of your brain patterns truly be you, or merely a doppelganger with your memories? Let's briefly consider the beloved lightsaber, a weapon of elegant impossibility. While plasma can indeed be contained by magnetic fields, the energy requirements and heat management issues make handheld plasma blades currently infeasible. However, directed energy weapons using lasers and plasma are under active military development. Perhaps more intriguing are defensive technologies like the shields in Dune and Star Trek. Current research into metamaterials that can manipulate electromagnetic waves, acoustic shielding, and plasma windows offer tantalizing glimpses of protective field technologies, though nothing approaching the comprehensive protection depicted on screen. The most perplexing technologies often involve power generation. The arc reactor that powers Iron Man's suit, for instance, would require energy densities currently unachievable with known physics. Yet research into nuclear fusion, antimatter containment, and novel battery chemistries continues pushing energy storage boundaries. The gap between fiction and possibility narrows with each breakthrough. What remains truly implausible today may become merely challenging tomorrow. After all, The communicators of the original Star Trek seemed magical in the 1960s, but look primitive compared to modern smartphones. Science fiction frequently examines the ethical frontiers of emerging technologies. Gattaca presents a society stratified by genetic engineering, where biological determinism has replaced social class with a new hierarchy based on genetic perfection. This once distant scenario grows increasingly relevant as CRISPR gene editing technology advances. We now possess the capability to edit the human genome with unprecedented precision, raising profound questions about the boundaries of intervention, consent, and the definition of humanity itself. Similarly, Jurassic Park explored the hubris of genetic resurrection and manipulation. While we cannot currently reconstruct extinct species from fossilized DNA as depicted, genetic technologies now permit the editing of living genomes and potential de-extinction of recently disappeared species through closely related surrogates. The film's chaos theory mathematician Ian Malcolm delivers the haunting admonition. Your scientists were so preoccupied with whether or not they could, they didn't stop to think if they should. This philosophical tension between capability and wisdom lies at the heart of our technological evolution. Environmental collapse scenarios feature prominently in science fiction. Blade Runner presents a world of perpetual darkness under polluted skies. Snowpiercer depicts an ice age triggered by climate engineering gone wrong. WALL-E shows an Earth abandoned after becoming uninhabitable from waste accumulation. These cautionary tales intersect uncomfortably with climate science projections and environmental degradation. The fictional scenarios serve as thought experiments exploring the logical conclusions of current trends, compelling us to confront uncomfortable possibilities. Yet science fiction also inspires solutions. Technologies like carbon capture, renewable energy, and vertical farming, all featured in various sci-fi works, are now being developed to address environmental challenges. Fiction provides not only warnings, but potential roadmaps toward sustainable futures. This dialogue between fictional apocalypse and technological salvation reflects our very real struggle to balance industrial development with environmental preservation, perhaps the most consequential challenge of our time. As our journey concludes, we must acknowledge the profound symbiosis between science fiction and scientific progress. The genre has directly inspired countless innovations, from communication, satellites proposed by Arthur C. Clarke to the mobile phone influenced by Star Trek's communicators, and tablet computers prefigured in 2001, A Space Odyssey. But beyond specific inventions, science fiction provides a laboratory for exploring the ethical, philosophical, and existential implications of emerging technologies before they arrive. It asks not merely what we can build, but what we will become through our creations. In this enigmatic dance between imagination and reality, between the technically possible and the wildly speculative, we glimpse both our potential futures and the timeless questions that define our humanity. The most profound truth may be that the boundary between science fiction and science fact isn't a fixed line, but a shifting frontier, one that moves ever forward through the combined power of human creativity and ingenuity. Thank you for joining me on this captivating exploration of the science behind our favorite fictional worlds. Until next time, keep questioning, keep imagining, and keep exploring the mysteries that lie at the intersection of what is and what might be. Music fades in for closing.